Hey everybody, hope you're doing well today. I'm going to be doing something a little bit different today. I'm going to be doing a little bit of, in this case, pre-recorded, but in the future, if this works well, we'll do some live coding sessions. Today, what I'm going to be doing is I have some of these NR52 840 development kits. These guys, and I'm going to be hooking them up and getting them communicating over 802.15.4. Now this is something that I have some ideas about, and I just wanted to try it and see if it worked the way I was expecting. So I'm going to run you all through the kind of beginning stages of getting everything working, and also I'm going to hopefully get these things talking together before the end of this video. So we'll see how much progress we can make. And first step is creating a project. So I was actually just on the Zephyr website earlier, and they have different ways of creating applications. So I prefer the Zephyr freestanding application, whereas your application lives outside Zephyr project itself. So we will be following that same idea, and I'm going to be creating a new repository, and I'm going to call it 802.15.4 experiments, just for now. So what it's going to do is I already kind of created a template that's pretty easy, straightforward to use, and I'm just going to double check. Okay, so I will have to update that, so it's not a big deal. I'm going to be using vanilla Zephyr today, no NCS. But I'm going to switch over. So I have the URL, the get URL, so I'm going to close this screen. And I'm going to change over to VS Code. Here we go. And I'll use this folder. And I'm going to be using this URL and the branch name. We're just going to be using the default branch name. So it's going to pull NCS. So I will have to update that. And then one thing you can do, I'm just going to adjust it right now. Is it just what I'm thinking about doing is it's just adjusting the manifest here. Let's see, I don't necessarily need that, but we do need this. And the latest version as of today is 3.2.0, and we can import, of course, all dependencies. We might not need that. We'll see. So it's still going to load all that stuff. And we might use NCS eventually, depending on the needs of the application. So you might as well just pull it down anyway. It's pulling all the, when this guy is active, it's going to pull down all the sub-dependencies of NCS. So it's going to pull down quite a bit of stuff. So it might take a hot minute. But once you have the SDK actually set up, it's pretty fast. So you don't have to worry about it after that. All right, all those guys are set. So I'm just going to re-update dependencies. Sweet. It might pull some other stuff though. Ooh. So you can see if you do not ignore certain entries, it will pull it. And one thing you can do is actually modify. And you can block certain things that you just do not need. So there's a whole list of stuff here that I don't necessarily need. There's one thing in this list that I do need, but I will get rid of that. And let's see, is there anything else that I would need? I think the rest of this stuff I do not need for now, so. Oh no. All right, so that will give us kind of the basics. Kind of getting rid of a bunch of stuff that's not necessary. And we have some boards. Of course, this is using the NR50 with 60 feather. So I will just remove these for now, but we probably will be using these later. And I'm gonna get rid of, delete everything. Delete, 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 delete. All right. Do 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 do. And experiment. And we'll get rid of that. And won't worry about this for now. Just kind of cleaning things up as necessary. I just want a really, really, really basic POC, proof of concept. I'll keep that for now. And what I'm going to do is I'm just going to set this up like Blinky application. So Blinky main should give us that guy, and we'll just copy paste. Just so we just have something to call the initial application. So don't think about too much what I did here, but I just kind of made things a little bit more simple just to start with. And we'll go from there. So see if I can build it. And we're using the NR52 840 DK with the NR50 840. I didn't know that the 52 840 DK had an 52811 on it. I didn't know that was true. So let me see if that works. Sweet. I'll unplug one of these dev boards, so flash. Oh yes. And we got a little blinky action, just like that. Oh no, I don't know if I can reach. You might have to take my word for it. It's blinking. Now, the cool thing is we can keep going. So the cool thing about Zephyr is that it comes with a lot of batteries including samples. So I already did some research, and I did know that there's some 802.15.4 samples in here, some of which are under the WPAN serial, WPAN USB. So I'm going to be setting up, I forget which one was the better one in terms of the closeness to my setup. So this might be a good starting point. They were actually using like a USB interface as well. We're not going to bother with that, but just to get things started. Get rid of these guys, get rid of these guys, get rid of these guys. Don't need that guy. So just making sure that this is showing up still. Okay, we're good. So what we can start doing is just importing. We can actually see what this project is using in terms of configuration, because that's going to be very important. We don't care about any of the USB, but you can see networking and the IEEE 802.15.4. We definitely want all that good stuff in our project configuration. So I would just, and I will move this out, configuration folder. And sure, why not? We'll add the settings backend as well. That might bite us, but we'll try it. Doop, doop. So you can always set logging. It's probably one of the first things that I do. This may or may not work with the dash. So let's see if it works. Okay, I don't think it would work with a dash here. Let's try it. Oh yeah, it's angry. So let's not do that. We can pull in some of these kind of critical. Zephyr includes. Cool. So a lot of this stuff, let's see, all this stuff is mostly related to. So we'll start at the main and kind of try to break down what's going on here. So might as well do a little bit of this. Can't write experiment today. And then we'll put the device in there. And sorry guys, whoever, you know, people might be better keyboard warriors than I am. So it might be painful for some of you, but try. Let's see. And he's getting, let's see, the device. It's right here somewhere. Where's the device? Okay, cool. So they're doing it the right way, which is good. So right here is where all this magic is happening, and then we'll go from there. So we're gonna get this, make sure this device is working. Oh, I kind of saw that coming. Man, the format is really slow today. Let's see. So that's complaining about the device API. Oh no, it's complaining about the device itself. So something is not telling the board that, or that the sample is using 802.15.4. So let's just check out Zephyr and the configuration. And 802.15.4. I'm just gonna make this bigger. But basically when it's trying to find it in the overlay and it cannot find it. So I have to look at what necessarily has to be done. Go over here, there aren't even any board files. Zero, blah blah blah. Show prompt. Just looking at OpenThread, which also uses 802.15.4. This is the NCP processor. OpenThread. So going back to the main, what's happening is it's giving me, so this is the nice thing about device DT-get, is that it will tell you what's going on in here. I'm trying to get this device, but it is not being found. So one thing you can do, we can look up that board file and see if there's any mentions of 802.15.4, 52.840, NRF 52.840.dts. This guy. Oh, it's right here. So why is that working, huh? Tell me that. Tell me that. Undefined reference to that device. So most likely there is a configuration that is not getting set. So, and I haven't played with 802.15.4 by itself and Zephyr. So this will be an interesting little dive. We'll go back to the configuration. 802.15. I'm gonna build pristine because sometimes it'll actually give you an error while you're building, and it's like, oh, you can't do that because that's not enabled yet. Oh, it looks like I just need a rebuild because this is actually, there's no device error anymore, but it is complaining about a thread net receive data. All right, we're making progress here now. So it looks like I don't have one of the network APIs turned on. So let's see if we can find it. Networking serial. What do we got on this one? missing something. Undefined reference to this guy. Let's just make sure this guy should be default on, so we'll just check out the config and make sure that's the case. So it looks like it's turned on. At least some of it is, and this guy's turned on. What? So let's find where this guy is located, because I think that will help determine. And what I'm going to do is I'm going to limit to .h files so I can figure out what the heck. IEEE. So it looks like some of these guys actually have this created. So I'll just throw this in main. That's interesting. Just for giggles. Alright, that got rid of that error, but undefined this guy. This is a core network call. Net core. Net core to C. Let's see if there's anything that requires. Let's make this. Yeah, it's like the core, one of the core networking. That's interesting. I'm missing something here. CMakeless IP. Does it think it's in raw mode? Aha. Thinks it's in raw mode. Do I have to implement it like some of those other samples did? Looks like that is the case. Huh. So some of these net calls are implemented manually. Fair enough. So I will leave that alone for now. Now, serial monitor. I don't know if it's ANC0. I have a feeling it's not. Oh, it is. Perfect. So now, cool thing about this board is that it's got built-in serial, and so I can actually pipe out the serial output, the default serial output, the console output to the serial using some of the Zephyr tools, which is pretty good. All right, I just closed everything. And I'm just gonna go back to this guy. All right, so we got the basics. We got it initializing. That's half the battle right there. So some of this stuff is not necessary. Oh, this is actually the other sample, huh? So we're basically in the process of doing this. Oh no. So they use the radio API a bunch, like initialization and filters, setting pan ID. So I think, let's see, right now it just uses defaults. But as you can imagine, let's do some of this stuff, shall we? And they use this instead, which is interesting. Casting the API. Ooh. Man. Just curious how they use it. Got it. All right. So let's initialize that. Pointer to this guy. So whenever you make devices in Zephyr, you can essentially create these structures that point to internal references to whatever that device has capabilities of. So get API from driver. So if we actually look at that, i.e. this guy, you go down to the bottom, most likely, here. You can see there's a bunch of macros and initialization and things like that happening right here. Those APIs are actually getting populated here, so the radio API. So this is actually the API that we're referring to. So it's just some crazy C magic to basically allow you to use it kind of in a closer context, rather than using just this guy with the pointer to the API and the pointer to the whatever. It's just directly to the API. Get MAC. Maybe they get a MAC address, I'm guessing. Interesting. So this is just setting an arbitrary MAC address. I don't think we have to worry about that for now. I think we're more interested in but I can kind of understand what we're doing here. Get capabilities. So basically, getting capabilities will return a bit mask, which will tell you what it's able to do. So all of these. Fair enough. So we're setting these filters, which is interesting that we're setting the address that way. So let's definitely set channel, because we know we need that. So, and we'll just be using the same defaults that are provided. Oh no, I actually want to see if they're actually are set in the configuration. They are. So by default, the pan ID is ABCD, channel is 26, radio power is 0. So those can be great defaults for if you're just testing and things like that. Cool thing is that you can use something like the shell to set those values to something else differently if you need to, or set them from Bluetooth or whatever you want to do. So we'll roll with that. And then, like, at the bottom there, we'll just do API start. Technically, that returns an integer. Let's take a look at this function and see what it does. So might be good to just see what happens here. If ret 0, log error, able to start 802, 7, 802, 15 for radio. So interesting thing that I've noticed is that I tend to try to catch as many errors as possible the more I code in Rust, which is kind of cool. It's unexpected, is that my C code has gotten better since coding in Rust, because it forces you to catch errors. So when I get through here, I'm like, oh, I see something that I'm not catching. It's like, oh, I've got to catch that error, got to make sure it's handled, because otherwise it will be a bad day. Let's see. I'm actually kind of curious if it will start just the way it is right now. So, radio. All right, no errors. So it actually started, the radio's on, no errors. So it's kind of cool. Let me see if I can figure out to set the pan ID. 1 second. I'll be right back.
A few moments later.
All right, back. I wanted to spend some time off camera to really kind of understand this code a little bit better. So one thing that I did is just kind of went through and understood some of the libraries, underlying components a little bit better, so I could kind of simplify this sample significantly. So one thing that I did do is, you guys saw that, I'll get rid of some of these. I had originally pulled in regular Zephyr. I just switched over to RF Connect. The reason I did that is I was looking at some of their documentation around the multiple protocol coexistence in the NRF52 series, and that is something that I'm probably going to want to set up. I do want to have coexistence between the Bluetooth side of things and also the 802.15.4. So that is something important there. Actually, let's see me NRF SDK. Documentation. Connect SDK to So I'm going to switch over the window so I can just show you what I was looking at. Oop, I closed it. And then I'll just make it a little bit bigger. Cool. They have some great documentation here in the NRF Connect SDK. One of the more important things to this particular situation is with all the 802.15.4 documentation. So in their NRFX lib, which contains a lot of their proprietary libraries, we can go down to the 802.15.4 radio driver. So this has kind of more of their more of the information on the driver. Go to the driver architecture. You can see how, you know, BLE and Thread/Zigbee are kind of coexisting together at the side by side. You have the open source radio driver, which is actually included in Zephyr, so you can use it in regular Zephyr if you want. The only problem is that MPSL, that multi-protocol service layer, is something that only NCS has. So that's unfortunate, but that's just the way it is. I kind of explained this in a previous video on comparing vanilla Zephyr to NCS, so I will definitely include that. I'm going to write that down in my notes to include that in the description below. So that's that. So I did switch that over. You saw earlier that I was setting the channel information, so definitely it was still happening. Also, so the net packet infrastructure does need to be initialized because we're not using any of the network APIs. We're kind of using the raw APIs for writing and reading data. And let's see. So we did this. So left off here. So I did some other things. I looked into the API, tried to understand how to modify it. There's this IEEE 802.15.4 config structure, and this allows you to set different modes of the radio, set it in a coordinator role versus just a regular device role. In this case, it doesn't really matter for me. I don't really care much about that information at this point. Honestly, I wanted to see if I can get a point-to-point radio setup working, and it seems to be working right now. But I'll show you guys what it. I will turn off the hex dump so you can actually see that I am receiving packets. Actually, I'll leave it on, but I'll explain what's going on in the terminal below. Of course, I have to change the window again. That would be good. So I set the channel, and then I was going to the configuration. I just showed the configuration here. This is all the configuration settings, but in particular, when you run this configure API call, you have different kind of things that you want to be changing. So you can set only parts of the config that you care about, and then the enum here will actually make sure you're only setting that particular config. So if there's multiple values, you might actually have to do one at a time. I'm not sure if there's not like a configuration all. You have to do a set configuration for every single one. So keep that in mind. And then what happened was I was trying to understand this hardware filter stuff. The NRF series, this is like the core idea of 802.15.4, just the down level or low level. The NR52 driver does support all this because it's important functionality. In terms of the filter, basically, right now, if you go back here, I set this radio to be receiving in promiscuous mode, which is like I want to hear everything. I don't want to filter out anything. So one thing that you can do is when you turn this mode off, eventually you want to turn it off, is you can filter by your address and also by the PIN ID, which is like your network ID. And these are things that you can set up at the beginning. So you only filter out the packets that you want, and these packets end up getting forwarded to your application in a callback here. So net received data is getting forwarded to this callback here, and that's how you get those packets without having to sort through them yourself. It's kind of done lower level, and then it gets forwarded on to the higher level APIs, which is fantastic. And the last thing you just need to do is make sure you just start. So when you run the start API, it actually enables the receiver so you can receive packets. Kind of important. So that in a nutshell is what it's doing in terms of receiving. Now what I did was I actually, on the other end, I actually created a while loop just so I could transmit some data. And what I did is I created a packet. It's allocating some space, I think, on the heap. Writing some kind of data to it, and then transmitting that data with some retries. So 3 times with retry. And I believe acknowledgements are turned on by default. So that's just something to keep in mind. And then let's see. And then the important part is because it is allocated on the heap, you just got to make sure that you free that memory before you do anything else. So that is getting freed. And then I'm just saying, hey, it's sent successfully. So if you go over here, I'm actually sending these. I'm actually not, this is not in promiscuous mode, so it's not receiving anything unless it's the same PAN ID and the same device ID, or the same short ID. So, but on this side, you can see I do get the occasional packet from something else. There is actually a lot of 802.15.4 packets roaming around my house right now. So that's something that's happening, but you can also see a lot of the test packets. So we got a data, we got a packet with the address of that packet. Let's see, let me see if I can find here. So we got, it's a length of 7, which is basically what we're looking for. And then I do a data dump, and there's the test string that I set up above. So it's just the test payload that gets transmitted here. So we're allocating the buffer, that's the string, and then we want to write that string to it and transmit it. So I spent some time, I actually almost got this working yesterday when I first started this video, and the only thing that was happening was the packets are getting filtered out because I was not setting up the packets properly to show the, or to set the address of where it was trying to send that data to. So whenever I sent it, it got filtered out by the other device. So it's just saying, I'm writing the packets, nothing's happening. So turning on promiscuous mode, open my eyes here to seeing the data that's coming over here. You can see the result, which is fantastic. So that's probably going to be the end of this video right now. I'm going to spend some more time in it and then do a different video in terms of making some more progress. I'm going to be focusing on setting some filters and transmitting with the appropriate data in those packets, so those packets get filtered into the device that I'm trying to send it to only, and then we'll go from there. So I really appreciate you being here. I want to hear your feedback on these videos. I want to see if these videos are useful for you, because I'd love to share them more. And as I continue working on this project, I think I'll be hitting a lot of different aspects of Zephyr that maybe you haven't seen in my kind of Zephyr 101 videos. So I'd love to share a little bit more. So hit that like button, hit the subscribe button, and stay tuned, because there will be more videos coming soon. See ya.